Hello and welcome back to another video from the Mathnasium. Exponents rule. Oh wait, I misread that. That says exponent rules, which means this is probably a sheet that Mr. Slagle is going to be putting 9 different exponent rules on, which means I should probably get a piece of paper and divide it into 9 equal segments. Okay, so we're going to be adding rules to this sheet periodically throughout the unit. So what I need you to do is get out a sheet of paper, divide it into 9 equal segments, and then sometimes we're going to jump back to this sheet and we're going to add a little bit. We might do it at the end of the lesson. We'll see. So let's go ahead and jump right in. Mr. Slagle, what in the heck is an exponent? Well, exponents are really very simple. An exponent came about because, well, people are lazy. Let's jump in the way, way back machine. Remember in elementary school when they were like, Timmy, 3 times 4, that means 4 plus 4 plus 4. It is repeated addition. Multiplication gives us a faster way to write addition. Super. Okay, that's great because 9 times 8, I don't want to write 9 plus 9 plus 9 8 times. That's a pain. Multiplication saves us time, energy. We know time is money. It's really saving you money. So what is an exponent? An exponent was like, someone was like, hey, I don't want to have to write 3 times 3 times 3 times 3 times 3. Why don't we just come up with a rule that allows us to write this really quickly? Okay, well, that's 3 multiplied 5 times in a product, so we're going to raise it to that power. Super, 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 super. Fantastico, fantastico. All right, so let's take a look here. Every exponent situation has what's called the base. There's our new vocabulary word. The base is what we're multiplying, and the blue thing up there, so if you have a to the b, a is our base, and b is our exponent. And this tells us how many of the base are in the product. Fantastic. So I'm going to take a look at a really quick little situation we got to be really careful about. Okay. So if I say like 2 to the 4th, right? 2 to the 4th is I'm multiplying a product, and it's got a product of 4 2's. So it's 2 times 2 times 2 times 2. If we want to simplify this, you can kind of multiply the pairs and then multiply the results of that. 4 times 4 is 16. Fantastic. How about negative 2 to the 4th? Oh, Mr. Slug, what are you doing to me? That's negative 2 times negative 2 times negative 2 times negative 2. What's that equal to? Well, that's equal to 4, that's equal to 4. This is also equal to 16. Interesting, interesting. How about negative 2 to the 4th without parentheses? Oh, there is a distinction between these. Be careful, okay? Be careful because, in this case, negative 2 to the 4th is, this has parentheses, so the negative is included, so that negative is in each copy of the thing we're multiplying 4 times. In this case, what this actually says is the opposite of 2 to the 4th. Well, 2 to the 4th is 16, so this must be negative 16. That's really what this means, the opposite of 2 to the 4th. And we have to be able, this can't be positive 16, because we have to have a way to write like 10 minus 2 to the 4th. If this couldn't be negative, then we'd have no way to subtract an even-powered exponent. So we got to be careful there. I maybe just went a little too deep on exponents. Also be careful, like if we have negative 2 to the 3rd, if you have an odd power, a negative to an odd power, negative 2 times negative 2 times negative 2. If you have a negative to an odd power, and you multiply these, that's going to end up being 4, and you bring down the other 2 times negative 2, which will give us negative 8. Okay, so we really need to be, that's a times, not a minus. Just be careful there. So let's go through, let's do some practice. Practice identifying the base or base says in each of these problems, and we're going to talk about that in just a minute. You can pause the video. Okay, here we go. All right, in this case, the base is 6, the exponent is 3. If we wanted to simplify this, that would be 6 3 times. 6 times 6 is 36, times 6 is 216. Fantastic. Okay, in black, let's take a look. Negative 20 to the 4th. The base here is negative 20. It's to the 4th power. I'm not going to multiply that out for you. I think it's basically the same as what I just did up above. In blue, negative or 1/3 to the 3rd. The base is 1/3. The exponent is 3. Okay, if we wanted to figure out what this is, well, we do 1/3 times 1/3 times 1/3. And with multiplying fractions, we multiply across the top. 1 times 1 times 1 is 1. 3 times 3 times 3. 3 times 3 times 3 is 27. Okay, now what's the base here? Is this 2 on the x? Is it on the 4? Or is it on both? Correct answer is this 2 is an exponent for only the x. The 4 has its own exponent. The 4's exponent is 1. So if there's no exponent written on something, in a product, the exponent is 1. So this would be 4 times x if we wrote it out long ways. Okay, super. Here's some more vocabulary for you. When we're dealing with these expressions that involve a product, expressions that involve a product can be written in 2 different ways. And this way over here, when you have it everything condensed down into one, you're going to hear me say, this is exponential notation. Okay, we have them condensed. Over here, this would be 4 times x times x times x times x times x. This is expanded. Expanded notation. I almost forgot that 4. You thought I was going to forget, didn't you? I didn't. Let the record show. Here we go. All right, so you guys take a second to try and write this. This one is in expanded. You're going to write it in exponential. This one is in exponential. You're going to write it in expanded. Pause the video. If you need help, I would imagine this is going to be a breeze for you. Okay, unpause. Here we go. 2 to the 7th. 1, 2, 3, 4, 5, 6, 7 2's being multiplied. In green, w to the 6, 6 w's. Not too exciting, Mr. Slagle. This is easy, Snorefest. Okay, let's do some harder ones. Okay, so now what we're going to do is we have things that are kind of partially expanded notation, partially exponential notation, and we're going to combine them together into one beautiful, simplified expression. Beautiful, beautiful, beautiful. 4 things being multiplied here. 4 times x times 8 times x. So the trick that I do for simplifying a product is I always take the numbers that are being multiplied and I separate them from the variables and put them out front. So we're going to write this as 4 times 8 times that times x times x. Now I multiply all the numbers that are in the product. 4 times 8 is 32. And then I consolidate or count the number of each variable and then write their exponent. So this is going to be x to the 2nd. That's this in simplified form. Okay, blue problem. All right, let's go. How many things being multiplied? Well, depends on what you're looking at. You could say it's 1, 2, 3 things being multiplied, or you could say it's 1, 2, 3, 4, 5, 6 things being multiplied, or you could say it's 1, 2, 3, 4, 5, 6, 7 because there are 2 x's and x squared. The choice is up to you. Just kidding. It's kind of 7 things being multiplied. Let's take all the numbers that are in this product. 6 times 2 times 3. Great. We've rewritten all the numbers. By the way, the property that allows us to do that is called the commutative property of multiplication. We can multiply in any order. 3 times 2 times 5 is the same as 3 times 5 times 2. 6 times 5 is 30. 15 times 2 is still 30. Okay? We're allowed to multiply in any order, so that's what allows me to change the order of this product. We got a bunch of junk being multiplied together. So 6 times 2 times 3 times x times x times x times x. So there's x squared. So how many x's did we have? 1, 2, 3, 4. For a total of 12 times 3 is 36x to the 4th. Kind of already did that problem on the first slide. Let's go on to green. You guys try this. Check your answer after you unpause. Here we go. Multiply the numbers. We can change the order that we're multiplying. So 3 times 5 goes out front. And then we have x times x times x times x times x. There's x squared. Here's x to the 3rd. 3 times 5 is 15. How many x's do we have? 1, 2, 3, 4, 5. I know what you're saying. Slagle, what are you doing? Why are you writing this out in expanded note? You could just look. X to the 3rd, x to the 2nd, there's 5 x's. Why don't you just go straight to the answer? Okay, we will be patient. It is rule number 1 that you're describing, so chill out. Okay, 3 times 5 is 15. We got 5 x's. Ladies and gentlemen, I do not expect you to write all of these problems out in expanded notation, especially not if the problem looks like this. X to the 19th times x to the 25th, okay? I do not expect you to write out 19 x's and 25 x's. That is a waste of your time. So instead, we're going to use this rule. Rule 1 is that when you have two bases being multiplied, or two numbers with the same base being multiplied, like a to the m times a to the n, then the result of, they have to have the same base, by the way, we are allowed to add their exponents. You're allowed to do m plus n. Whoa. Slagle, you're saving me all sorts of time. You're welcome. Whoa, what happened? Wait, whoa, okay. There we go. 2 to the 2nd times 2 to the 3rd, what is that? Well, these numbers have the same base. The base is 2 in the product. Hey, we can add their exponents. That's 2 to the 2 plus 3, which is 2 to the 5th. All right. So this is it in exponential form, which is great. 32 is the actual value. The way that you'd get that is by writing them out again and doing that in pairs. 2, 2, 2, 2. Bring this one down. 2 times 2 is 4. 2 times 2 is 4. Take the product of those. Multiply by 2. 4 times 4 is 16. Bring this down. Times 2 is 32. Fantastic. And if you look right here at the very beginning, 2 to the 2nd is 4. 2 to the 3rd is 8. And 4 times 8 is 32. Fantastic. Fantastic. Let's keep going. All right. Look at this one. Take a guess. See if you can figure it out. We have 3 numbers in a product. Okay? 3 numbers in a product that are being multiplied, so we can add their exponents. All right, so I know what you're thinking. Some of you, I saw what you did. You were going to say x to the 8th. It's not x to the 8th, because remember, if there is a base that doesn't have an exponent is 1. So you got to be real careful here. To show our work, by the way, this is how I want you to show your work. You're going to say x to the 5 plus 1 plus 3 in the power. 5 plus 3, it's 8. 9, x to the 9th. Looking good, looking good. Next one, in blue. You try this one by yourself. Check your answer in 3 seconds. Okay, to show your work, you're going to do w to the, these two numbers have the same base, add their powers. 19 plus 4 is equal to w to the 23. That's rule number 1. Awesome. Remember that. Don't forget it. Maybe pause the video, write it in the first box on your sheet. Okay? I don't want to go back. I'll do them all at the end. We're going to save some time. Don't let me forget. Put it in the top left box. Top left. Rule number 1. We're going to keep cruising. Let's do some harder examples. Ew. Okay, now we got, this is getting interesting here. We've got 6 times x to the 3rd times 7 times x to the 112. Don't write this out in expanded notation. Instead, let's do 6 times 7 times x to the 3rd times x to the 112. So what I did is I wrote the numbers on the left being multiplied. We have a product. There's 4 bases that we're multiplying here. 6 times 7 times x to the 3rd times x to the 112th. 6 times 7 is 42. Let's multiply those numbers. Now let's apply our rule, which is 3 plus 112 in the exponent. That's 42 times x to the 115th power. Fantastic. We can add those together. Definitely don't want to count all the x's. That would be horrible. Okay, in green, you're trying this one on your own. Give it a shot. Give it a shot. See if you can get the answer. Pause the video or try and beat me. Maybe you can be faster than me. I have 1, 2, 3, 4, 5 things being multiplied. Let's write our two numbers in the front of this product. Okay, so 2 times 6, and then y, it'll be y to the 5th times y to the 2nd times y. Okay, so that's going to be 2 times 6 is 12, and then y to the 5 plus 2 plus 1. Remember, there's a 1 here. We got to be careful. If there doesn't have an exponent, the exponent is 1 in this case. Okay, 5 plus 2 plus 1 is y to the 8th. Fantastic. In red, give it one more try. I'm just going to do a bunch of problems. You can pause the video if you want to try and beat me to it. All right, how many different bases we got? 1, 8 is 1, c is 2, b to the 6th, 3, 4 is 4, c is 5, c to the 3rd is 5, b to the 2nd is 6. So we got 6 things, numbers out front, 8 times 4, and then what I like to do is if you have two variables that you're dealing with, typically mathematicians always want to have a rule so we all get the same answer. And the way that we do that is we're going to write them in alphabetical order. So we'll do b's first, times b to the, let's add their powers, 2 plus 6, times c to the, add their powers, 1 plus 3. Our final answer here is 32, b to the 8th, c to the 4th. Last one of this kind before we do 19 more. All right, number of bases. 10 is 1, y to the 2nd is 2, 14 is 3, y to the 9th is 4, y to the 3rd is 5, and y is 6. Let's do it again. So this is 10 times 14, and then you're going to have y to the, let's just go right to this step, 2 plus 9 plus 3 plus 1, which is 140. Y to the 9 plus 1 is 10. 2 plus 3 is 15. That's it. That's what we do here. Time to move on to rule numero dos. Get ready for this one. Strap yourselves in. Okay. So what happens when I am raising something to a power that already has a power? Let's think about this. Whenever in doubt, go back to expanded notation. Think about what that means. Well, 2 to the 2nd, that's 2 2's in a product, and that's being raised to the 3rd power. All right, so what this really is it's 2 times 2 times 2 times 2 times 2 times 2. So how many 2's is that? It's 2 to the 6th. Oh, look at this. What operation can I do with 2 and 3 that will give me 2 to the 6th? Okay, we could have also written this as 2 to the 2nd times 2 to the 2nd times 2 to the 2nd, which is 2 to the 6, or 2 plus 2 plus 2, okay? Repeated addition. Guess what repeated addition is, folks? Multiplication. Remember? From the way back machine that we did earlier. 2 to the 6th. Anyways, this is not the way I want you to do this problem. This is the expanded notation way to do the problem. The way that we do it is we apply Rule 2. Rule 2 says a raised to the m power raised to the n power is actually a to the m times n. So we can come down here and we go, hey, this is 2 to the 2 times 3 which is 2 to the 6th. Hey, remember before when we were like, Slagle, what's 2 to the 5th power? Where was that? 32? Well, 2 to the 6th, you take that, multiply by 2 one more time. 32 times 2 is... So 2 to the 6th is your answer there, which is 64. So what is this rule written out? When we raise a number with an exponent to a power, we multiply the exponents. All right. Not too shabby. Not too shabby. All right, let's do this thing. We're going to do these. Let's just do them all. We're going to jump into this. Okay, in green. Hey, look, that's x to the 19th to the 3rd. So all I got to do is x to the 19 times 3. Now, what I'm giving you is the shortcut, right? If I did this the long way, it'd be 19 times x to the 19 times x to the 19th. Then we got to add them all up, and there's 3 of them. Why don't we just multiply by 3? It's going to make things easier. That's x to the 57th. Coming on down. Whoa, whoa, whoa! What is this, Slagle? First you raise an exponent to an exponent, right? You're raising a base with a power to a power. That's a problem. And now you're doing it again? What is wrong with you, Slagle? Come on. So here's what we're going to do. What we're going to do is we're not going to think about it as a big mess. We're just going to focus on a very small portion, and that very small portion is the inside. X to the 3rd power raised to the 2nd power. So again, we're not raising 3 to the 2nd power. We're raising x to the 3rd to the 2nd power, which means we're going to do x to the 3 times 2, but that's raised to the 4th. So this is actually x to the 6th to the 4th. And now we can apply rule 2 again. We're raising x to the 6th power to the 4th power, which means that is x to the 6th times 4. Whoa, Slagle, what the? X to the 6 times 4, which is x to the 24th power. Great, 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 great. Okay, last one. You can do that. I believe you. Believe in you, rather. I don't know if I believe you. Let's see. Key distinction there. M to the 13 times 4 is what we're going to do, which is m to the 52nd. Rule 3. Let's jump in. Let's take a look at this example in green so we can kind of prove our rule, and I'll show you the way that I would do it. Okay, rule 3 says, what happens when we have a product inside parentheses and we're raising those parentheses to the power? Well, it just means you have whatever that is multiplied 3 times. So this is not applying rule 3. This is doing it the long and arduous way, which we really want to try and avoid. It's x times y times x times y times x times y. How many x's do we have? 3. How many y's do we have? We have 3. Okay, so why did I do that? Why didn't I just, there's 2 bases in there, why didn't I just raise them each to the 3rd power? Well, it turns out that's what rule number 3 is. There are 2 bases inside parentheses, and those parentheses are being raised to a power. All we have to do is raise the first to that power and second to that power. Cool. So the real way that you should have done this is really you can kind of, just skip this step altogether and go x times y to the 3rd. Well, we raise them both to the 3rd power. So what if they already have a power? Well, then we get to apply rule 3 and rule 2. Interesting, interesting. So if we're applying rule 2 and rule 3 here, what do we do? Well, how many bases are on the inside of the parentheses? We have 1, 2, 3, 4. 1, 2, 3, 4 bases on the inside of the parentheses. So what we are going to do is we're going to raise all 4 of those to the 3rd power, and this is how you do that. That's negative 3 to the 3rd times x to the 8th to the 3rd times y to the 10th to the 3rd. Now this looks like the distributive property. It's not the distributive property. That's different. That has to do with distributing multiplication here. We're kind of, we're using the power, I call it basically a product to a power. When you have a product to a power, you are raising each element of the product to that power. So y to the 10th goes to the third power. W to the third goes to the third power. Okay, negative 3 to the third is, oh boy, go off on the side if you need help. Negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Times negative 3 is positive times a negative is a negative 27, right? So this is negative 27, and now we can apply rule 2, power to a power, or raising a base with an exponent to a power is x to the 8 times 3 times y to the 10 times 3 times w to the 3 times 3. We're raising all of these who already have an exponent to a power. All right, that's x to the 24th times y to the 30th times w to the 9th. Oh no, they're not in alphabetical order. Slagle, you're breaking your own rules. You know what my mom always used to say? You make them, you break them. I don't know if anyone else's mother said that. But w to the 9th, x to the 24th, y to the 30th. I know my alphabet, I think. All right, you try this last one. Last problem. You got this, team. You got this, team. So you're going to go and you're going to raise... pause, sorry, you pause the video. Make sure you pause. Try it on your own. There are 3 bases. We're going to make sure we raise all 4 of them to the 4th power. So the way that we write that is going to be, that's 2 to the 4th times x to the 4th times y to the 3rd, y to the 3rd to the 4th. 2 to the 4th, 2 times 2 is 4, so 2 times 2 times 2 times 2 is going to be 4 times 4, which is 16. Okay, again, if you need help with that, you just write it out like so. Okay, 4 multiplied 16. 16 times x to the 4th times y to the 3 times 4. So your final answer here is 16x to the 4th, y to the 12th. All right, your assignment is on, let's see, oh man, what the heck. Perfect. It's on my open math. Eraser. So have fun with that. And we're going to, some of them are going to be a little challenging based on what you've seen. We're going to do some more problems in class. And bolster your skills with this until you're comfortable. All right, guys, thanks for watching. I hope you enjoyed this video brought to you by the Mathnasium. Peace.